Hello, everybody. My name's Michael Overstreet. I'm a roboticist and computer programmer. I'm here today to talk to you about robotics and automation in factories and businesses and so on. You have a lot of questions about factories, so we can talk about factories for a little bit, and then we can then talk about where robotics automation will show up in other businesses and even in your homes and so on. So most people, when they think about factory automation and robotics, they think about robot arms. I'm sure you've seen lots of videos. I can share my screen and try to help you out here, show you what I'm talking about. So most people, when they talk about automation in factories, we're talking about robot arms. And since Tesla is pretty advanced in that field, I can kind of show you a video. So a lot of factories, especially cars and manufacturing factories, are using robotics, automation on the assembly lines. That's where most of the robots, automation is going on right now in the U.S. Like I said, Tesla is a good example. They're very advanced in their use of automation and robotics. And you can see they use these big, humongous, gigantic robot arms to build the cars. And you can see they can lift really heavy objects, thousands of pounds. And so the reason why lots of manufacturers, especially cars manufacturers, are going to robotics is because before the pandemic, there was a lot of open job openings, and they were having trouble filling positions and getting skilled labor and workers. Also, automation. It's safer on the assembly line for the workers. And yes, it does make the cars a little bit cheaper because the robots are less expensive. So it's a kind of a trade-off. There's a lot of advantages to using robotics automation on assembly lines. Makes the cars a little bit cheaper. It's a little safer for the workers. And like I said, so it does displace some workers, but building a car is a very advanced, skilled labor. So it's sometimes been hard, especially in years past, to fill positions. And like you can see, this is what people think about with the automation. So there's just trade-offs. There's advantages and disadvantages to automation. So I kind of want to not scare you to think that robots and AI and so on are going to take jobs. There's lots of really cool jobs are now opening up because of robotics and automation. So just think about it. Somebody has to build the robot. Somebody has to design the robot. Somebody has to program the robot. And then also on the assembly line. So, now I'm getting kind of stuck. So now think about it. Robots can do one task at a time. You can program them to do one task at a time, but robots can't. Robots don't know how to build a car. So they have to be trained and taught and programmed how to build a car. So that's where the humans come in. So the humans design the assembly line, they design the car, they design how to manufacture the car, then they train and teach robots how to do each individual station, and then you need technicians to maintain the robots, fix the robots, and so on. So, like I said, there's lots of job opportunities being opened up in that area. So just think of STEAM education areas like electronics, mechanical engineering, electronic engineering, computer programming are all valuable skills for people to learn, to work with and be with and work around and maintain robots. So, and this goes through this. So I try not to make this really complicated about how to program the robots, but that's one of the most important skills because somebody needs to design the assembly line, design, a robot doesn't know how to put this dashboard in. A robot has to be trained and taught how to put this dashboard in. So let me pause this for a second. So in today's robotics and factories and automation, they use a technique very similar to, I don't know if you've seen claymation movies, stop motion movies. With a robot arm, how you train the robot arm is if it doesn't know how to do a task, you actually move the arm through the different individual steps, and then the different servo positions like the elbow and the joints and the fingers and whatever are all programmed by actually moving them around and doing the task, just moving the robot arm around and doing the task. And I like to use the claymation example as a good example because all of the limbs. That's kind of what you're doing. You're building a task for the robot by slowly moving it around and doing its small incremental steps from to build its action. And like you said, claymation is a great example of how the robotic, basically stop motion, capture motion occurs. Instead of taking a film, you're basically training the robot arm to do its task. Hope that makes sense. And then, so behind the scenes, you've got a human training the robot, moving the robot around, and and teaching it how to put in the glass there on the top of the car. And that's how robots are programmed now. Most robots in the factories and most robots you see are basically taught, especially the robot arms, are taught through actually moving the arm and getting to do what you wanted to do, and then fine-tuning it, adjusting that, and so on. Now, in the future, there's going to be a lot of other job opportunities and possibilities out there. And so in the future, AI, machine learning, and data will allow, and virtual reality will allow you to train the robots virtually. So think about it. You'll have instead of having the factory and physically moving the robot arm around, you will have a virtual simulation, a virtual 3D simulation of the robot and of the factory line. And then you will have each individual robot station, and then you'll take the virtual robot and you will move it around on your computer screen and program it that way to do each individual step. And the great thing about that is that you can virtually simulate the entire production line. You can run virtual simulations of the production line and of putting the card together or whatever you're putting together. And then you can make sure everything works without spending a lot of money and time and effort into building and producing the factory line until you're ready. So virtual reality, 3D stuff, even though 3D goggles, you'll be able to use those to help program and design an assembly line in the future. So that opens up all kinds of new job opportunities you can think about. So when you're doing programming in Minecraft and some other stuff, you're learning some of the basics you'll need. And if you're into virtual reality and gaming and stuff, you'll learn some of the skills you'll need in the future when you start doing these virtual simulations of factories and businesses and warehouses and so on. Programming. So like I said, in the future, AI, machine learning, and programming are going to be huge valuable skills for you to have so that you can program the robots, develop the robots, design the robots, and so on. So I can't tell you how important. I know math can be frustrating at times, but I can't tell you how important learning mathematics is, learning math, using basic math. So the more work you put in high school and junior high and grade school in your math, the better prepared you're going to be when you try to go out into the workplace and do computer programming jobs, electrical engineering jobs, mechanical engineering jobs, and so on. I would recommend, if you don't have one, talk to your parents about getting something like the Raspberry Pi. And while I like the Raspberry Pi is a small little computer. It runs on Linux. Linux is an operating system. Most of you are probably using Windows or maybe Mac OS or Mac. But in the field of robotics, learning Linux, Ubuntu, and so on, and learning how to use this small computers like this will be great for you in the future when you're trying to do some electrical engineering, mechanical engineering, robotics type stuff. It also is great if you haven't used Scratch before. Scratch is a great way to get started in computer programming. And the great thing about the Raspberry Pi is that Scratch is already built in. And you can learn how to use Scratch, learn basic programming skills. Great way to get started. And then the cool thing about the Raspberry Pi is that once you've got your basic programming and computer skills down, you can move on to more advanced stuff like learning Python. Python is a high-level programming language. So I recommend first start with Scratch and then maybe moving on. Once you've got the skills down there, move on to stuff like higher-level language like Python. There's a lot of cool Python stuff built into the Raspberry Pi. And then if you're really interested in robotics and all the things around robotics, I would definitely recommend that if you have a Lego League in your school or you have a VEX competition in your school, and then when you get try to get into those groups and learn what you can about robotics. FIRST is also a great, once you get into high school, FIRST is great too. And because there's all kinds of cool things you learn in FIRST, teamwork, projects, how to build, design, work on robots, how to get robots to do what you want them to do, and so on. That you're going to need to learn and get good at. I can't emphasize to you enough how math is important. I know math can be frustrating at times, but the more work you put in now with the basics, the better you're going to do in high school and college. You get high-level skills and so on in classes and that. Usually, when I work on robotics projects, I work on a team, and there's lots of different skill sets within that team. So if you're not really good at computer programming, but you're good at mechanical engineering or electrical engineering. They're also very valuable skills. Also, somebody has to build and fabricate the robot. So that's why I'm saying mechanical skills, electrical engineering skills are really valuable. Somebody's got to prototype the robot, has to build the robot. And then, like I said, somebody needs to program the robot. You also probably need like a project lead, somebody who can talk to the client or the customer. And then you also have like testers, beta testers. I do a lot of beta testing. I get a robot and then I get an early prototype robot and then I'll help program it and modify it. Iteration basically means that you make small little steps instead of going from nothing to completed robot. You do small incremental steps where you build something, test it, make sure it works, modify it, build it, test it, modify it, get it to work, and eventually, over a few iterations, at a few cycles of build, prototyping, testing, you'll get the completed robot ready to go. And then, like I said, then there's going to be somebody that needs to work with the client. Tesla's a great example. Tesla doesn't build their robots in-house. They buy their robots from a robotic company who specializes in robot arms. So that company has a team that works and develops and tests and programs that robot. That team will then work with Tesla to integrate that robot into the production line. And then, like I said, in the factory, robots can't, they don't know how to build a car. So what happens is you have somebody in the factory, you have a group in the factory of employees that know everything about that car, know how to put the car together. They can put the car together by themselves or in a group. But then what they do is they then build the assembly line. They break the assembly of the car down into small little steps that a robot can do. And then the robot will then do its small little function, its small little whatever it is, put the window on. Like I said, this video is great about showing. So each robot does one small little step. One robot does not build the entire car, but like I said, there's a little, you can see here, there's a little assembly line where the car slowly moves down the line. Here, there's a painting station. You've got multiple arms that have spray adapters at the end, and they spray their section of the vehicle. And then, like I said, in the factory, you've got groups of people who know how to put the car together step by step, and they train the robots. And then you're going to need somebody. You're going to need maintenance people. You need to need somebody to maintain the robot, check that, make sure it's working functionally properly. So instead of putting the car together, you're going to have people who have programming skills, electrical and mechanical engineering skills, so that they can repair the robots and fix the robots, maintain the robots, add more robots to the assembly line. So that you're going to need somebody to just the general infrastructure of the factory. You're going to need people to make sure that the robots have all the materials they need, because a robot arm will, if it runs out of bolts and screws and attachments and spray paint, there's going to have to be somebody to maintain that stock for the robot. Because if let's say you have a robot that has to do a lot of screws or bolts, what happens if that robot runs out of screws and bolts at its station? Right now, you're going to need a human to make sure that that's fully stocked, because you don't want the assembly line to stop just because one of the hundreds of robots doesn't have a bolt, a screw, attachment, or let's say one of these spray robots runs out of paint. You don't want to hold up the entire factory line for hours waiting for somebody to get paint for that robot. So you need somebody to make sure that the factory is fully supplied, the robots have all the materials they need to build the robot. So what I'm trying to say is, don't be scared that robots are going to take over and that robots are going to take all the jobs. What's happening is robots will do the simple tasks, the easy tasks, the repetitive tasks, and the humans will do all the smart stuff. We'll do all the stuff that takes thinking and takes creativity and so on. And so that's a kind of a long-winded answers to the different people I work with, but I work with all kinds of people during the day. I got, like I said, electrical engineers, mechanical engineers, computer programmers, project leads, business leads. I actually have talked to people whose sole job is to communicate with the customer, send emails and send communications back and forth and talk to them on video conferences like this. Then we need testers, beta testers. So, like I said, for Tesla, they buy pre-made robot arms from a robot company. So that robot company first has to build those robots, maintain those robots, test those robots, and then when Tesla buys them, they work with Tesla and the workers at the plants to integrate the robots into the factory, train up the workers on how to use the robots and program the robots. So all kinds of job opportunities out there. So like I said, I really would encourage you to think about STEAM activities, and Bex and Lego and FIRST. And then when you get into college, you can get into electrical engineering, mechanical engineering, programming. There's actually lots of jobs out there for people to do 3D design, CAD design. So somebody has to make the blueprints, the designs for these robots. So they use 3D software to build these robots, and so on. That's kind of a quick overview. I think I've hopefully answered all the questions that you had about the pre-questions you had for me. Is there any questions I could answer? I got one question. Yeah, somebody said they're working on programming. That's a great skill to have. I definitely would recommend at your age level that Scratch is a great place to start. It's online programming environment GUI that you can use, and its building blocks is very similar to what you do with Lego. And I definitely recommend that you would start there. And then once you've learned all you can about Scratch and basic programming, then you can move on to something a little high level like Python. And the reason why I say Python is because a lot of businesses are using Python now. So that's something in high school and in college that you would start going to. The videos I'm showing with the car, I'm just trying to show you how a manufacturing and automated process works and how it's all broken up in small little steps and they put the car together. I like using Tesla as an example because Tesla is very advanced in the automation and use of robots within their factories. What do I build? So I personally work on, I don't know if you know what 3D printing is. So 3D printing is where you take a design that you make on a CAD program, like Fusion 360, Autodesk. Where's a good example? Oh. Here's my 3D printer. I don't know if you've seen a 3D printer before. I do a lot of CAD design, and I build robot prototypes. And then once I've designed them, then I 3D print out the parts. I like to use this guy as an example. So all the gray parts you see are 3D printed. So what happens once we've got all the 3D printed parts so they work the way we want them to work, then we can use other manufacturing techniques like injected molded plastic or metal fabrication. But the great thing about 3D printing is that I can prototype the robot. I can make sure the parts work correctly. And then once I know everything's working the way I want it to work, like I said, iteration, I just slowly design and change the parts until the way I want them. And then we can move on to mass production of the parts. So I kind of specialize in prototyping and 3D printing out of prototypes, and then, like I said, beta testing.
Somebody says they see the blue robot behind you.
Oh, yeah. So this little robot is called Snow, and we can get into, there's other types of robots. So right now, most of the robots you're going to see are in factory lines and warehouses. So Amazon has robots that put together all your packages for you. Now the next wave is going to be social service helper butler robots, and that's kind of what Snow is. So I know a lot of people probably haven't gone to a fast food restaurant lately, but before COVID-19 hit, a lot of these, McDonald's is a great example. Before COVID-19 hit, a lot of the McDonald's were going to those big, huge, kiosk ordering stations. And instead of talking to somebody, you put your order into the big screen, and then it processes your work and so on. So there's now work being done. Instead of just having a computer screen, like at McDonald's, you can have a robot. So when you come into the place of business, the robot will be there to greet you, say hello. Snow has a camera, and then she can see who you are and take a picture of who you are, and then get your name and then store that in her database. So that's what I'm saying. There's cloud robotics. There's other AI, machine learning. So I'm working developing her to be smart and use AI and machine learning. She can take lots of pictures of people, and then we have a database behind the scenes that stores all the pictures. And with each picture, it will store your name. If it's your picture, it'll have your name, who you are, and information about you. So if you show up at a place of business, let's say you have to go to the doctor's today, or the dentist office, or the eye doctor, and you have an appointment, when you walk in, and if the robot already has a picture of you in their database, which it's a big, like it's all stored on a computer or a server somewhere, then Snow can, through her camera and facial recognition, so your iPhone, or a lot of the phones now have facial recognition on them, so they have a picture of you. So when you put it up, they're locked, and you put it up to your face, they see your face, and then through facial recognition and all the pictures they have stored of you, they know it's you. And Snow is the same way. She has a camera, and it has that information stored. So if you walk into a place of business and you have an appointment, Snow can actually drive up to you autonomously, do this all autonomously by herself, and recognize who you are, see who you are, know your name, talk to you, and then they can also notify the doctor or the lawyer or the dentist or whoever you're here to see, and kind of like a receptionist. And then she can actually, through autonomous navigation, she can actually take you. If the office is big, she can actually drive or go to, on her wheels, she can move and drive autonomously to the door of the room that you need to be in, and then she can make sure that you're following her. And then once you get there, She can say go in or notify the doctor, and you go into the room, kind of like a receptionist. So there's all kinds of things she could do other than that. She can, if you come into a museum, even if you come into the school with her camera, she can say, do you have a face mask on? Are you running a temperature? She has infrared sensors. She can check, make sure if you're running a temperature, if you have a face mask on. And then if she's got your picture, she knows that you should be there. And she can allow you access or into a business or a school or whatever. So that's a great question. So robots not only are going to be in factories, think of all the cool things robots can do to help us out. They can take over some of the boring, easy to do jobs. Like, why have somebody take, like if you're at McDonald's is a great example. Why have somebody take the food out from the kitchen to your table? You could actually have a robot do that. That's pretty easy. You can put the food on a robot has a tray in front of it. You put the food on it, and then the robot autonomously moves to your table. And also, it's great for today's world. It helps with social distancing and PPEs and so on. A robot. The great thing about a robot is a robot can't get sick, and a robot can't make you sick. So robots are great in that they can help us alleviate some of the social distancing stuff we have to do. You don't have to social distance with a robot.
And we have more questions on here. Michael, there's a question. What keeps the robots running?
Okay, so that's a great question, because that's something somebody's going to have to do. Somebody has to maintain the robot. So now in a factory situation, the robots are all connected to a power source, hydroelectric or just pure electric. So, but a lot of robots in the future are going to be self-contained. They won't be connected to a power source. Like Snow here has a huge, so you actually have a battery inside your phone. So Snow also has a big, huge battery down here in her base. So she has to periodically charge her battery after about every 6 to 8 hours. She has to charge her battery. So if she can't do that on her own, if she doesn't have a little base station, so you like those vacuum cleaner robots, if you've seen those, they all know how to get back to their charging station. Now, if she doesn't have a charging station she has to go to, somebody has to plug her in, and somebody has to recharge her. And so, like I said, in factories, it's not as big of an issue, but as robots come into the house, into businesses, you're going to need to make sure the batteries are maintained and charged. And either a human does that, or you're going to have to make the robot autonomously do that.
I think Ms. Cotton is ready to end this session.
Okay.
Do you have any closing remarks really quick?
I would definitely encourage you to work on STEAM and STEM classes and education. And like I said, with your age group, I would definitely start with Scratch. And if you can, you don't have to, but if you can, I would definitely recommend that you get something like the Raspberry Pi or the Arduino, the Microbit by BBC is also a great place to start learning how to program and use robots. And then if you have the opportunity, I would very much encourage you to do Lego, Vex, and FIRST in school. And then, like I said, once you get out of high school, then if you go into college, programming, electrical engineering, mechanical engineering will get you ready. You could even do 2-year schools where you get a mechanical, electrical engineering degree and so on. So there's futures bright. So I definitely would encourage you to jump in, and especially if you enjoy robotics or programming.
Awesome. Thank you so much for your time today, Michael. We'll see you guys later. Bye.
Bye, everybody. Thank you.